Hi guys. So what this video is if you missed our lab on making clouds, I'm gonna just kind of walk you through the process so that you can understand and be able to fill out your worksheet that you should have put into your notebook. Okay. So there's really two steps to this lab. The first step is just understanding how pressures will affect temperature of an enclosed space. So we've got our bottle. The bottles that we used are going to have some water in them with some probably used matches. They're not going to affect this lab at all. So they're just there for the second part of this. So the first part, what you've got, I have one of these very expensive thermometer strip on a string. You get these I got them at PetSmart. They're, if you peel off the tape, you can stick them onto aquariums so they will tell you what temperature it is. We're going to use these so that we can record the temperature of what's going on inside of this bottle. So, and how you read these, by the way. You've got squares that are lit up. Those would indicate to you the temperature. But notice how there are two squares. One at the 71 and one at the 68. So you would kind of just go in between and say that temperature, I would say the 71 is a little bit more strong colored, so I would go for 70 if I were to just do that. We're not going to really be doing this for specific temperature, just more of a general thing. So we're going to put the thermometer strip inside and suspend it and really get a good close on that lid. So notice that the thermometer strip's not touching the top or the bottom. So what you're going to do first, what we did was we took the temperature on inside of the bottle, mark that down, and then the students are going to squeeze the bottle and keep a constant squeeze on it so that every 30 seconds we'll check it and write down our results of how much the temperature changed. So as the students are squeezing the bottle, it's a constant squeeze. Their partners are checking the temperature and keeping that. And sometimes it's kind of hard to squeeze this bottle for a full minute. But what you are trying to do is you are decreasing the amount of space that's inside this bottle. When you decrease space, all the air molecules are stuck inside of there because we trapped them, and they have nowhere to go. So you're closing them off into smaller spaces. So now they're bouncing all around. They have less space. That is going to give you an increase of temperature. In which case they're just going to bounce into each other even more and continue to increase that temperature. Just like if I were to say, all right guys, today class, we're going to go into our small science prep room instead. Everybody would hate me because that temperature in there would very much rise because all of you would be forced to be under a much more confined space. So after squeezing this, I don't even think it's been a full minute, I'm going to check the temperature. And I can tell you from what I'm reading, it's about 76, 77 degrees. So it rose by about 6 or 7 degrees just from that probably 30-second, 45-second minute, 30-second time spot that I squeezed the bottle to make it increase. So that's just a nice little segue into our next round, understanding that by squeezing the bottle, we increase the temperature. By releasing the bottle and letting it go back to its normal spot, if you were to check the temperature now that it's been about 30 seconds, I can tell you right now it's already down to 74 degrees. So it's decreasing now that I'm giving the molecules back their airspace. So compression makes higher temperature, and then expansion, giving them back their space, expansion, makes them cool off. So knowing that trait and understanding how this bottle will work will come in very handy when we are going to be doing our cloud making. So again, from what I've just talked about, you should be able to answer your first 3 questions on your worksheet. So for the second part, we're going to take our thermometer strip out. And next up, for making clouds, there are a few key components that we need. We've got our water, okay, very much needed. Clouds are a part of the water cycle, so we need our water. Also, what we're going to do is we're going to be trying to create condensation. Condensation is what makes clouds. We need it to go through a cooling process. That's what condensation comes from. So from water vapor turning back to water droplets. And we'll talk about that in just a second. But that cooling process we just figured out by releasing the bottle and letting it expand back out to where it was. It's a rapid cooling process. So we figured that part out. And the third thing that we need is smoke. Okay? Smoke, if you didn't know this, is not just gas. Sadly, they are little solid tiny particles. And so every time you breathe in smoke, that's why it's so bad for your lungs, because it actually stays in there. It's solid little particles. So whether it's cigarette smoke or car smoke or factory smoke, smoke from the city or pollution, all of that stuff actually has little tiny solid particles. Those are very much needed here. So we're going to light the match, and we're going to very quickly close with the match lit. We're going to put it inside of the bottle, close it up, trying to trap as much smoke in here. The water at the bottom of this is going to extinguish the flame. So no worries about fire hazards. Okay? So you light your match. And then you let it in there. Okay? So by doing this, we did not need that match for heat. Remember, we already figured out how we can increase the heat. If we want heat, we just got to squeeze this bottle. That match was needed for those solid particles of that smoke. Because without smoke particles, we would not have very many clouds. So it's a good thing we want clouds. But too much pollution will create a lot of clouds, which we call smog, if you've ever been to a big city. Okay, so now our bottle is prepped and ready to go. So what we're going to do is squeeze our bottle. Okay, so while I'm squeezing it, I'm looking on the inside of here. I'm not seeing any clouds. I'm not seeing clouds because the temperature inside of this bottle is increasing. Right? We're squeezing, we're increasing, we're cutting off the space, so we're making it, making those air molecules bounce all around. And you just learned that warm air can hold more water vapor. It's more humid in there. So all that water vapor that is evaporating in there because of the warm temperatures is easily being held by that warm heat inside the bottle. Warm equals good for humidity, okay? Which is terrible for clouds because clouds are made up of tiny water droplets. If they're being heated, those droplets are going to be evaporated and turned back to gas. So you have to have a cooling process. Again, clouds are made out of water droplets. So if it's really hot, then those water droplets are just going to turn back to gas and vaporize, and the cloud will disappear. So we need to go through a cooling process. We need that water vapor to turn back to water droplets to give us a cloud. So, increase in temperature. Now we're going to decrease temperature by releasing. It's really hard to see, okay? I'm not even quite sure if you can tell on this. Nope. You're going to just have to trust me on this one. The video is not going to pick this up. But clouds just look like fog. They're not these puffy white cotton ball type things. If they're in such a small space, they're not going to be these big puffy things that you imagine they should be. Sadly, I'm sorry, that's not true. So it's just going to be really foggy. So again, we've made a cloud because we've decreased the temperature. The water droplets were able to form because cold temperatures cannot hold water vapor very well. So it turned that water vapor that had been just everywhere, really hot, sticky, humid air that was inside of that because it was so warm. And as soon as we cooled it down, that cold air couldn't hold that water vapor anymore. So it turned it back to water droplets. Okay, kind of like when you're outside and you're running around. If you get cold, if you go running outside like, you know, in the middle of winter time, you get cold, you shrink together. You go, I don't want to be bouncing everywhere. I don't want to be crazy. I want to conserve my heat. And that's really what water molecules are doing. If they're bouncing all around in the hot air, they're going to vaporize. And that air can hold it. But if they're cold, they're going to shrink together where they'll condense and become the water droplet forms. Okay? So when I squeeze the bottle, my cloud disappears because, again, I've increased the temperature and now the water droplets in my clouds have vanished because that warm temperature can hold that water vapor now. Okay, so now we're back to humid. Humid means very little clouds. Okay, then if I want my cloud to reappear, I just let go. Did you see the fog? Okay, I can see it. I'm sorry that maybe you can't. So every time I squeeze, cloud disappears. Let go, cloud forms. Squeeze, disappears. Let go, let it expand and cool down. My cloud forms. So again, condensation created the cloud because it's going from water vapor to water droplets. And by squeezing it, I've increased the temperature, which means I've made it go through evaporation. Evaporation kills clouds, makes them disappear, because that warm air can now suck up all the water droplets from that cloud and hold it as water vapor. So, all right, I'm pretty sure we went through every part of your worksheet. You should be able to answer the questions. Remember, number 8 talks about why was the match necessary? Because it had those small particles inside of that smoke. It was not the heat. Okay, you don't need the fire. You need the smoke, and you need to explain why you need the smoke. When those, sorry, I didn't explain that. So when the cloud is trying to cool down and go through condensation, okay, when they're all crazy, hyper, overheated, evaporation's going everywhere, you super cool it down, and it shrinks back together. Okay? It needs something to grab onto when it does that. Those water molecules are going all around. If you have smoke particles in the air, it gives them something to latch onto. It's like the glue that holds the cloud together, allowing it to stay. So that's why we needed the smoke. We needed those solid particles to allow the water molecules to cling onto it when they condense. All right, so from there on, you should be able to finish your worksheet. I'm sorry that you can't see the clouds through the webcam, but you can just imagine. So let me know if you have any questions. Bye.